current here. So let I be the current entering, and that much of current should leave that particular junction. So here, let it be I1. And now you can ask question, why you are branching the same current? So look at the branch resistance AB, AD, and A, 3 ohm. And look at the junction D, B, and E also. B is connected to C by 6 ohm. So look at this path. And it also connected to C, like a 6 ohm. And is also connected to this one. This look at there's a outgoing current here, no? So the B wattman junction B is connected to outgoing terminal through 6 ohm and 2 ohm. Similarly, you see this. Even this also. So therefore, what about D and B? So writing loop equation, writing KVL, I directly conclude that. So it will be like this: VA minus 3I1 minus VB equals 0. Then VA minus 3I1 minus VD equals 0. VA minus 3I1 minus V equal to 0. So with this, what we can write? VB equal to VD equal to V with respect to what? With respect to A. Similarly, on the other side, this current I1 now it will come. So what happened? This current, it will branch out. It will branch out. So how to do that branching here now? Now let's look at the current I1. When it arrives at B, it will branch out here. So divide this current as say I2. Let this be I3. Similarly here also, this will be I3. This will be I2. This will be I2. This will be I3. So I2 plus I3. I1. I2 plus I3. This should be I1. I2 plus I3. This will be I1. So what current entered? I equal to 3I1. It's the same thing, no? I is equal to 3I1. Then, what we can write here now? Potential of C. Potential of C equal to F equal to H. They are equal with respect to what? With respect to G. Now, what to do with equipotential points? So I identified like this the equipotential point. After identifying them, I'll make them common. So this is a BDE. BDE. Then HFC. Then this is G. Now bring the resistors between. This will be 3 resistors, 3 ohm, 3 ohm, 3 ohm. From B to C, 6 ohm. Then B2F will be 12 ohm. So how many like this? I think there will be 6 resistors, no? So 3 6 ohm resistors and 3 12 ohm resistors will be connected.
Sir, how did you get VF?
What do you mean by VF? VF is here, no? VF minus VG.
In that equation, equal to VC and VH.
Write KVL from F to G, H to G, and C to G. This one, okay. Applying KVL from again what I did for VA to VB, no? Similarly, you write KVL VF minus 2I minus VG, VH minus 2I minus VG, VC minus 2I VG. So VG is the common
Okay,
terminal.
sir.
And that one. Between HFC, this will be 2 ohm resistance will be there. This will be. So how do the circuit? The circuit is simple series parallel, no? Unless they made 3-dimensional. Okay, got this. So what you have to check it, this particular thing. Somehow what happened? You have to make the circuits simple series parallel, then we can manage it. I think 3 ohm. The resistance will be just 3 ohm. RAG will be 3 ohm. The value of RAG will be. So how to divide current? So the biggest problem is what, like not like identifying the potential. Symmetry in the sense here, the potential. So now you can say everything is fine. A redrawing circuit, as everyone knows how to redraw, how to write KVL. What is the biggest problem? How to assume the distribution of current? I think there's a really the biggest thing. That's the biggest hurdle. Once you know how to distribute current, problem is solved. We can write all these equations. There's no problem with this equation. Everyone is good. No problem in redrawing. But what is the biggest headache for you? How to identify, how to branch the current. So you can't just take any particular formula. What you do, you make observation. Look at the path A, B, C, G. A, B, C, G. So what is the path? 3 ohm, 6 ohm, 2 ohm. Then again, you look at this part, particular path. A, D. So again, DH and I. Okay, the same, similar to that path. So again, look at this particular thing. It will branch out, no? Here, you can see here also, it will branch out. The idea, no? So when the current comes, it will branch out. Here also it will come, it will branch out. So similarly, you see this one, this will branch out. So look at this particular junction EDB. They are what, like similar junctions. The similar junctions sense same resistance 3 ohm, and DB are similar junctions. So therefore, when I write KVL, I'll end up with same potential. Not if I by some means if I make this 9 ohm, gone. We can't do this problem. We have to apply any KVL or any other method. We can't simplify the method what we used here. Got this? So definitely if they give problem, so it will be like something based on some symmetry of distribution of current. You have to look at the path from where the current entered to the where current left. Not just only this one. Means if I make this 2 ohm, then again, so we can't work out here.
Sir, can you repeat the second thing, sir? Second equation.
This one, huh? VA minus 3I1 minus VD equals 0. This one only?
Not that, sir. VC is equal to VF is equal to VH.
How I got it up better? I think I'll write it. Everyone is asking. I'll write this equation. VC minus 2I1 minus VG equals 0. VF minus 2I1 minus VG equal to 0. VH minus 2I1 minus VG equals 0. So finally, what do I end up? Okay. Fine. Just writing KVL, nothing big. Only the distribution of current is something very important that you have to manage here. Let me give another thing. So where we have to apply many concepts here, not one just equipotential. Drawing circuit.